Good morning, everybody. Thank you so much for joining us today on the Z Exchange. Just to go over a couple notes before we get started, we are recording today's session. You'll have the ability to get a link to the recording, and I will be emailing everybody after the presentation. So if you would like to request the link to that, please feel free to reply to me there. We also have Q&A available throughout today's session. So if you have any questions, feel free to pop them into the Q&A box. That being said, thank you again for joining us today for Driving Real-Time Intelligence with AI on IBM Z and LinuxONE. Today we have Steve Warren here. He's the Senior Technical Staff Member and Principal Solution Architect at IBM's Washington Systems Center. Steve helps IBM Z clients modernize their environments with hybrid cloud and AI. With that being said, I'm going to hand it over to you now, Steve.
Thank you, Sammy, and thank you, Jerry, and thank you to New Era Software for putting on these great um, technology exchanges where we can disseminate information to the users of the ZOS and IBM Z and LinuxONE platforms. So, with that, thank you for the introduction. It's always a passion of mine to talk about AI on the IBM Z platform, and hopefully you will get a better understanding of how business applications can take advantage of AI on the platform and to leverage the power that it comes with the IBM Z hardware since the IBM Z16. And so with that, we'll move on again. Let's feel free to ask questions. You can just click on the question and answer section if you have questions, and we'll try to answer as many as we can in the allotted time. So with that, let's get going. So let's first talk about the three different types of enterprise AI before we talk about AI on Z. And we hear lots of things about many of flavors of AI. There's the buzzwords of the day, and there's also real value in some of those buzzwords, right? So generative AI, our world has been transformed by generative AI, whether it's Microsoft Copilot, ChatGPT, Google Gemini, or any number of models that allow you to have a productivity increase by being able to discern text and be able to give an intelligent response based on your questions. And so we've seen that take off in the last number of years. ChatGPT is only a few years old that really started this generation of really having generative AI capabilities. There's also agentic AI. And agentic AI, sometimes paired very closely with generative AI, really seeks to help you automate and orchestrate a lot of the things that you do on your system, to be able to get access to live information, to be able to take automated actions based on some kind of prompt maybe that was given or some other action that has taken place, and to be able to use AI in conjunction with tools and different tasks to accomplish a goal. And then there's this one called transactional AI, and it's highlighted in blue, not necessarily because it's any more or less important, but it's one that we typically overlook and one that Z plays in very well. And that's called transactional AI. And that transactional AI is really the idea of improving real-time decisions with predictive models in your transactional workloads. So we'll talk a lot of the differences between predictive AI versus generative AI and talk about where there's a role for each of them to play and how they can all work together in many cases to have a more comprehensive solution. So transactional AI is infusing into your business applications that are running throughout your enterprise with additional AI insights that you could not normally get from just doing simple rules-based type of analysis, if then else statements, for example. So we'll be covering this and talking about all three flavors of these throughout our talk today. So the idea is here, before we go on to the Z, this is the last high-level slide before we dive into the technical details, is that when you make AI improvements to your business applications, for example, even a small increase in your decision-making capabilities can result in huge bottom lines, right? So this is just sort of highlighting the fact that AI is an incremental improvement, but that incremental improvement can be in millions of dollars. And in some clients' cases, it can even approach the B word, billions of dollars in savings by being able to view a problem from a different angle by looking at it from a pattern-based predictive framework and or leveraging generative and agentic capabilities. So it's uh, this improvement is transformative, but it can be done in small pieces. So now let's talk about why deploy AI and Z. So we understand the basic concepts of AI. We understand that even making a small improvement in an insight can result in a lot of money. Why on earth would we deploy AI on IBM Z? So of course we know we're preaching to the choir by the audience that's represented here today that Z, IBM Z, in particular ZOS, has tremendous capabilities. And when we talk about ZOS, we also talk about Linux on Z, LinuxONE as well, about the amazing capabilities on both the hardware and the operating systems that run on this amazing platform, right? And we already know that we have a lot of the world's mission critical data runs on the mainframe. We know that a lot of the transactions that are processing our business workloads are running on the mainframe. And we know the mainframe has certain inherent capabilities that are listed on the upper right hand corner here: security, resiliency, scalability, performance, availability, and more. So the idea is we have this great platform that is very secure, provides lots of great business continuity. But then when we do an AI request, we go off the platform. That doesn't really make a lot of sense in many cases. We'll show you for the use cases where it doesn't make sense and show you use cases maybe where sometimes it is okay to go off the platform. The idea here is in this case, though, why not bring AI to where your data and applications are rather than trying to farm that off to some other platform? So we'll talk about this a little bit more and sort of build this idea out over the next hour. Okay, so why location matters for AI decisions? So a lot of folks have this very methodology for no other choice of words. I'll call it cloud first mentality, where everything should go to a public cloud as the first solution. Well, if my business and data, my business logic, my data are on the Z platform, if I go off platform for AI and then come back, the speed of light, last time I checked, hasn't improved on 186,000 miles per second, right? There is going to be some amount of latency. And it's not just the latency of the stuff going over the wire. It's the stuff that is building the packaging up all of that data that you need in order to make an AI decision, sending it across, unpacking it, getting it to run on a particular GPU or some other platform where you can do AI scoring, then repackaging the results, sending it over the wire, unpackaging it, and sending it to your resultant place. Now, for some types of workloads, it may not make a difference strictly from a sense of online transactions running. That if it takes 50 milliseconds or if it takes 5 milliseconds, it might not make a big difference. But when you congeal that with many hundreds of thousands of transactions running all at one time, or if you don't want to elongate a batch window where you want to add an AI score, but your batch window already is the maximum length it can be or doesn't have a lot of wiggle room, and so I can't afford to elongate that batch window longer. So this is where having very fast inferencing makes a big difference, right? It allows you to do those real-time scoring when I have the AI model co-located with the actual business logic and data, right? Okay. Now we also know about there are risks whenever we move data too, and some of it is a compliance risk, and a lot of it is a security risk, right? So every single time I make a copy of that data, I need to be able to protect it, and I might not be able to do that under a certain guidelines, whether it's DORA or some other guideline that requires me to protect that data, to delete that data, etc. Right? we know that a lot of the breaches in data that resides in the mainframe are not on the actual copy that's on the mainframe, but on these shadow copies that are all over our enterprise, right? And so, of course, making as few copies of our sensitive data is going to be of the great benefit. And I'm going to go to the last bullet here and talk about expense. A lot of times when we think about moving data to and from different platforms, we don't think about the monetary consequences with that. There is a monetary consequence, and it is significant. You pay, when you use ZOS TCP/IP, you pay MLC, monthly licensing charges, for that data to be sent off the platform, right? So from a ZOS, you pay money. From a cloud expense, every single time the cloud, sometimes when you're dealing with AI, deals in these ideas of tokens. Every single time I use a token, it costs money. Whenever I have cloud egress costs, that comes into play. And then there's also the idea of energy consumption. If I have, for example, an on-prem AI that's not on my platform, I have to pay. I have to factor that into the picture. So on Z, all these things are solved for these transactions, high volume transactions with very low latency, with very high level of security, not making lots of copies with it, being able to do it within the scope of a transaction, within a batch window, in a very fast way, and again, the cost advantage of not having to move data and having a minimal energy footprint. So there's a lot of positives, and for certain use cases, AI on Z or AI on LinuxONE makes a whole lot of sense. So again, the transactional AI embeds machine learning models directly into those transaction systems, and we're basically able, instead of waiting for off-platform AI, we can inject those insights directly into the flow of our transaction. So,
Steve, we did
yes,
have a question come in. I'm just going to interrupt you for one moment.
sure.
Either answer this now or when you're ready, but I just wanted to let you know we had a question come in that says in regulated industries, financial services, how can LLMs be trained when they do not have access to the software applications that are protected by multiple layers of security firewalls?
That is a great question. So that is really awesome. The I will defer that question a little bit until later on when we talk about large language models in here. So right now I'm still talking about machine learning models, which are predictive AI. So I don't know, Sammy, if you had a record of that question that we can revisit when we talk about large language models. But
Absolutely. Let me know when you're ready for it, and I will shoot it
okay.
back to you.
Okay, that would be great because that there is a the Z platform does support large language models, and we want to make sure that we fully understand that and that we have the regulatory compliance with using large language models. And so we'll talk about that in just a moment. Okay.
Wonderful. Thanks, Steve.
Sure. So let's go back to this now. Again, so when we're talking about running with predictive AI, we have the ability with pattern recognition using all the different techniques that you can use with machine learning and deep learning to be able to inject those things directly into the workflow. And you'll see with the Z17 that aperture has widened even more about the types of models that can run within the scope of a transaction, right? So imagine that I can flag fraud before I approve or decline. So there's a phrase out there which I always have to chuckle about. It's called near real time AI. Near real-time AI is a euphemism for not real-time AI. It means sometime quite close to where the transaction is, I'm going to have a score. Meanwhile, I let that transaction go through. It's completed its process, and now I have to pay and chase, so per se, if, for example, it was detecting fraud or if it was detecting some other kind of a problem, I have to now try to go after that thing which I've already let go and try to rectify the situation, right? This is talking about adding AI right within the scope as I'm doing the credit card auth, as I'm doing the auto adjudication, as I'm doing the retail uh, I'm sorry, product recommendation, et cetera, et cetera. I'm doing it right in the scope of that transaction, right? So you can see that the value is here when time matters. And you'd be surprised the use cases where time does matter. Now, as we mentioned before, time is not the only factor of why you use AI on Z. But there's a number of things. I mentioned batch workloads, which you would think would not be time sensitive, but they are in many cases. We can think of like things like product recommendations, but we want real-time product recommendations. We don't want product recommendations even 5 seconds after it happens because we talked to a retailer. Let me give you just a simple use case. They said uh, the the retailer has an app where you opt in to say that while you're in the store, it knows exactly where you are because it can give you very good recommendations. And as you're walking up and down the aisles, it says when you are approaching a particular area, it wants to give you a recommendation before you pass it more than 10 feet. If you pass the thing more than 10 feet away, it's a lost opportunity. The odds of you turning around and going back are very low, right? So again, even in retail, real-time instances where, some people don't walk normally in a straight line in the store, so you don't want to give the recommendation until they're right on the item that you want to recommend to them. And so even in this case, it matters. So the idea is that speed does matter, but so do all those other things about cost, about security, etc. Okay, so here's some of the high level things of how transactional AI can help you with in revenue growth, cost reduction, and risk management. We're gonna tease some of these ideas out over the next period of time, but I just wanted to give you an idea of what some of the possibilities are. And we've seen through countless interactions with clients use cases in almost every imaginable area. I've learned so much about how companies really work from some of the workshops that we do, where I ideate and come up with use cases that would benefit the client and leverage the existing investment that they've already made, right? So again, to summarize, before we get into the actual technology, even just 1 to 2% outcome improvement can save you millions of dollars. And we're saying with transactional AI, that is a very attainable goal of just a couple percent improvement on a outcome. And so let's move on and talk a little bit more about the technology. So we started out a number of years ago with the IBM Z16. So the IBM Z16, which I'm guessing some folks on this call have in their possession right now, has had the industry first on-chip AI inference accelerator. So what that means is a accelerator that is on the same piece of silicon as your cores and your cache and all the other things that are on that Z16 Telum processor. That's the name of the processor that we called it, right? Telum. So that dedicated accelerator works in conjunction with your general processor, and it has direct access to both the memory and cache. And on the next slide, I'll show you a picture of that in just a moment. And so what it allows you to do is, because it's on the same piece of silicon, I'm able to take advantage of that of some speed of light considerations that it's really going about a couple millimeters between your core and your actual on-chip accelerator. But this on-chip accelerator is designed for inferencing, optimized for inferencing. What does that mean? An inference simply is it's the model is making a decision. It's giving you a score. And maybe that score is between 0 and 1. And the closer it is to 1, the more likely it is to be fraud. The closer it is to 0, the closer likely it is to be not fraud, right? And that's just an example in a fraud situation. And there's many scores of use cases. So the bottom line is the mathematical operations that a typical model does for machine learning and deep learning, many of those can be accelerated by usage of that on-chip accelerator. So by doing that, it's really a game changer because I'm now able to deliver on a fully configured Z16 machine up to 300 billion inferences per day, all of them with an average response time of 1 millisecond. So that is mind-boggling. It is amazing for machine learning and for deep learning models. So how's that compare to going off platform? Well, we've done a number of different benchmarks, and we found out that ZOS can deliver 20%, 20 times lower response time and 19 times higher throughput when I co-locate my AI model with my business application and data, as opposed to going off platform. Okay, so that's what we deliver in the Z16. We'll talk about that optimized AI stack in just a moment. I just want to show you the how it actually looks like on the X-ray of the silicon. So if you see these square boxes here, these square boxes represent the cores that you're running here. So for example, they could be general purpose processors, they could be zip engines that you could run there. They could also be IFLs if you're running in a LinuxONE Z or LinuxONE. Here is down below, underneath this red is a little piece of white real estate here. That is the AI accelerator. Just like on the Z14, we greatly improved the encryption accelerator, the CPAC-F chip. On the Z15, we added the ZEDC accelerator. On the Z16, we add the AI integrated accelerator for AI on chip, right? So in the middle here is the level 2, level 3 cache. If my core is processing a particular model and it needs to do a mathematical operation that the AI accelerator can handle, all that data is in the cache. The AI accelerator has access to this cache. So now you can see how it's possible to run these somewhat complex deep learning models, for example, and be able to do it with a 1 millisecond, 3.5 million inference requests per second with 1 millisecond response time. So this is just really mind-boggling, the capabilities there are there. Okay. So there's a comment here. Real-time fraud detection is essential in ATM transactions. Once the cash has been withdrawn, it can be difficult to claw back. Exactly. That's that traditional model. Thanks, Bruce, for that comment. Pay and chase is a problem where a lot of clients say that if they let something go, it's very hard to get that money back. And I'll show you a couple of use cases where we've had clients tell us exactly that they need to catch it before they authorize or approve or adjudicate or whatever the case may be. Okay, so that was the IBM Z16. That's one generation of technology from where we are now. The IBM Z17 and the LinuxONE 5 box introduced what's called the Telum II chip. The Telum II chip is IBM doubling down on the AI capabilities of the mainframe. This second generation of the on-chip AI accelerator not only runs those models that ran on the Z16, it runs them a lot faster, but it also allows you now to do LLM compute primitives. So what do we mean by that? There's a different classifications of large language models. Some of them are called encoder large language models. That's the ability of a large language model to be able to decipher unstructured data. In other words, for example, read medical notes. I can read that. That's a lot what when you're talking to Copilot or ChatGPT, when you're typing in the prompt, it's using an encoder large language model to actually decipher that prompt and to make sense of what is being said, right? That is actually much easier to do than what's something called a decoder model. A decoder model is to generate new content. That is really the concept of generative AI, is when I take a decoder model and I actually generate a response back to that person. So when you go to ChatGPT or Copilot or Gemini or pick your favorite model, when it replies back to you, it's going to give you a response. That takes significant more compute power. So what we're saying on the Telum II processor is that we allow you to be able to decipher unstructured data within the scope of a transaction on that on-chip accelerator on the Z17. So that's one of the things that the Telum II processor provides. The second thing it does is it improves quantization. Okay, what is quantization? So in a nutshell, in a very simplified way, quantization is taking large numerical values that have a lot of precision, like floating point 32, and imagine if I can convert an input into a model instead of a floating point 32 into an integer 8. An integer 8 has much lower precision level, but if I'm able to use some very creative techniques, I can get that model that uses integer 8 to be almost as accurate as the one that used floating point 32, but it runs a whole lot faster with the smaller inputs. So that's what the idea of quantization is, and it supports improvements in that space. The next thing in the middle here is talking about in-drawer intelligent routing. In-drawer intelligent routing is basically saying, you know that accelerator that's on the Telum II processor? What if people start going crazy and using everything AI and eventually that accelerator becomes busy? Hmm, that could affect my throughput because now I have this accelerator that is just busy spinning there, and we need to be able to offload that to maybe one of the other chips in the drawer that also has that accelerator. So with the Z17, we allow for this in-drawer intelligent routing. For however many chips you have within a CPC drawer, we allow you to route the work over, and the accelerator makes that determination, and will only route it when it's absolutely necessary, right? So now we have additional throughput. Have we had clients saying that, my accelerator is really busy on the Z16, please make the with additional throughput capabilities? We haven't heard that, but we are one step ahead of the curve. We don't want to be hearing that as clients are leveraging, and now they're not running one or two or three or four, they're running 10, 20, 30 different type models on the machine. We want to make sure that we have the throughput capacity for the machine. Okay. The third item is on the right side, and this is what's referred to as supporting generative AI and large language models on the Z box. And we do that through something called the IBM Spyre Accelerator card. The IBM Spyre Accelerator card is a PCIe attached card that provides additional compute power to allow you to run selected generative AI models directly in the box. Now, are these going to be transactional in nature in terms of the speed? No. Generally speaking, these are going to be for non-transactional workload that I don't want to leave the platform. Could be for compliance, for security, or for other reasons. We don't want to have that flowing that data off of the platform. So in that case, the Spyre Accelerator can help facilitate that and to run generative AI directly on the machine. These are sold in groups of 8, and each one of the cards takes a very small 75 watts per card. So you can have up to 48 of them in a single box. So we'll talk more about that. Not really part of transactional AI, but it's part of the generative AI that you can run directly on the platform. So to summarize, on the Z17, where we could before do 300 billion inferences for machine learning and deep learning, on the Z17, we can do 450 billion. That's a 50% increase. We've also allowed you to have a higher throughput by having the drawer routing. And again, a very compelling story from a power perspective. The Z, very energy efficient and green. It's part of your sustainability solutions for your client, for your installation. So with the Z17, now I can do inferencing like I did before with the Z16, but I can add to that inferencing large language models to the mix because it supports that. I can do assistance like any kind of a code assistant or any kind of a assistant to help with AI ops and productivity. And I can start to use agentic AI and the agentic AI capabilities, which we'll talk about in just a couple moments. Okay, lots of information there. Let's keep moving. So this chart is one of my favorites because I know what a lot of folks are thinking. They say, okay, great hardware. No one's doubting that you have amazing hardware with the Z17 Telum II chip and the Spyre Accelerator. Wonderful. But if it doesn't run the AI models in the AI frameworks that my data scientist is familiar with, I'm not interested in this because I'm not going to have my data scientist do a one-off for deploying a model onto Z compared to where he deploys models throughout his enterprise or where she deploys throughout their enterprise. So I will tell you that middle column is so important. IBM has spent a ton of money to have an optimized AI stack that will run the AI frameworks and runtime environments that your business applications are demanding, or your data scientist says, in order to be able to have the insight that we need for your particular application, I need to use, I'll just pick one, scikit-learn or TensorFlow all these things you don't need to understand as a system programmer, but if you ask a data scientist, are those things important? Yes, they need to be able to run those things on the platform where these things are running. So what's nice about this AI framework is that the execution environment for your model running on ZOS or running on LinuxONE is able to handle any of these common frameworks transparently to the data scientist. In other words, the data scientist is just going to build and train their model anywhere, like on what it says here on the right. Build and train anywhere. If I'm used to building and training my model in a hybrid cloud, in a cloud environment, using AWS or using my platform of choice, continue to do so. But when I deploy my model, now I'm actually going to deploy it to IBM Z, and the data scientist doesn't need to know how to spell Z per se in order to deploy it onto the platform. So that's the joy of this particular solution, is that we have an ecosystem where we have a huge open source community of stuff. We'll talk about that in a couple slides from now. So the AI discussion that we have here is divided into two major camps. One is intelligent infrastructure on the right, and there's lots of great solutions to help you manage your mainframe better. And so, and or to be able to do, code generation. So we have all kinds of great solutions on the right-hand side here. Whether it's having ZOS take advantage of AI itself, or being able to have streamline your mainframe operations with Concert or watsonx Assistant for Z, conversational AI, all these great productivity gains. On the left-hand side is business AI infusion. And I'm going to argue to you for a moment that while the right side has tremendous value and we should definitely pursue all those things, you're not going to save the amount of money to your corporation and to make Z a very compelling space as much as you would on the left side. Business insights, sometimes changing one application, you save every year 20, 30, 40 million dollars a year by having this additional insight. It might take a while for you to get that amount of productivity on the right-hand side. It's not saying you shouldn't do all those things, because we need to do more with less, and to modernize our code and to be able to do AI ops in a more effective way. What I'm saying is that the left side sometimes gets put aside by assistant programmers, because guess what? This left side involves more than just us. We have to get other personas involved, and we'll talk about that in just a couple of moments. But here are some solutions that are available. Some of these solutions in the business insight space are no charge. So the AI inference server from Red Hat and the AI toolkit for IBM Z and LinuxONE, no additional charge. DB2 for SQL data insights. If you have DB2 version 13, you have DB2 SQL data insights. So some of these things are no charge. Other things are a paid product. We believe that there's enhanced values that would make them compelling to consider. So these different environments we'll talk about very briefly when we talk about deploying models and the deployment environment that a system programmer would typically set up. Okay, so if you're a system programmer right now, these icons of these various platforms are Greek to you, and they were Greek to me when I first joined. I was in ZOS development for over 25 years. So I know all about the fact that these are Greek. The key is, if I can take my model and get it into either running it native in the case of PyTorch or TensorFlow, I can run those natively right on ZOS and optimize those accelerators, or on LinuxONE Z or LinuxONE. Or I can take one of these model formats and export it into an interchange format like PMML or ONNX. Now, just to give you an idea, Open Neural Network Exchange is an open source standard. Do you know who some of the contributors are to this ONNX standard? This is not just IBM. This is NVIDIA. This is Facebook. This is Oracle. This is Microsoft. This is AWS, and more. They all are a contributor to the ONNX specifications. So we're taking a format that is readily accepted as a format in the industry and saying, you have one of the models in one of these formats, you can convert it into ONNX, run it through something called our deep learning compiler, and it will run directly on Z. So very powerful capabilities. So let's say there's a question here. Scott. Okay, hi Scott. The question is the advantages of in-transaction AI and Z systems are obvious. Once the time-sensitive nature of the scenario is eliminated, was the argument for doing say generative AI on Z systems was the comparative cost all in hardware, software, storage between a Z systems box versus an x86 NVIDIA GPU solution? That's a very great question. So we mentioned that in transaction is not always just time sensitive. Of course, it's related to security and cost of sending the data, ingress, cloud egress, etc. That being said, what about for generative AI solutions? So in some cases, as I said, for machine learning and deep learning, it can be about cost. I mean, it can be about speed, but it can be about other things. In the case of generative AI, when we're using those Spyre accelerators, for example, what is the total cost um, involved with the comparative cost? So in some cases, it can be very obvious. In some cases, we would ask that you do an IT economics study to fully realize the benefit because it depends on a lot of variable factors, right? Uh, and that can depend on what are your current cloud costs, what is the resiliency of that public cloud solution compared to your Z solution, uh, and much, much more, right? And again, the generative AI solutions that we have on IBM Z for using the Spyre Accelerator is not just about speed. It is about potential costs, which again, you have to do the study, and also about security of that data. A lot of the generative AI that we do on Z, our clients have said we don't want to necessarily have farmed out into the public cloud. So the short answer is, and it's a kind of a roundabout way of saying is, of course, IBM's favorite answer is it's going to depend a lot on the circumstances, and that we'd have to probably do if you really want a very in-depth study, you probably want to do something like with the IT economics team in IBM to give you a more comprehensive view of the cost savings. I have seen those comparisons done, and it is very compelling because if you're trying, they say, I want my public cloud to have as close to the same resiliency as the mainframe. Of course, it's never going to be there. But if you want to have all the cloud features turned on, including disaster recovery and the throughput requirements that you may have, you're going to see that the cost is in most cases very favorable from there, let alone the security and all the other factors and speed of those transactions. So I guess my answer is that unfortunately I can't give you just a single one size fits all for comparative costs between the platforms without knowing a lot more details. Okay. Let's talk about the AI use cases. So there, in every industry, whatever industry you're in, there are use cases for you in an AI and IBM Z, right? So financial services, very obvious benefits because of very tight SLAs that they have, and to be able to do some of these things. We'll show you some simple as well as complex ones. But you know what? There's fraud in every single industry. So even though fraud, we always assume it's with financial segment many times. There's a lot of fraud that we've dealt with many other industries. We've dealt with a travel industry, and we've seen people that say that there's a lot of fraud and gaming of systems in the travel industry, in insurance, in government. But it's much more than just fraud. It's intelligent underwriting, being able to do things in a more automated fashion. It's about doing audit and compliance in a more automated fashion. We'll show you some of these use cases as we come up in just a few moments. So here's the classic one, and we always lead with this one first because it's the one that's the most easily consumable, and that is credit card fraud. A client tried to move their data, tried to move their AI, well, they didn't move it. They actually tried to build an AI solution on-prem x86. They said, okay, single source of truth is on Z. My business logic is on Z. When a credit card transaction comes in, it comes into Z. And then I want to do an AI score. I want to do that off on an NVIDIA GPU on-prem on my X80 on x86 platform. So guess what? When they did that, they were only able to score about 10 to 20% of those in real time. Why were they only able to score about 10 to 20%? Because what ended up happening is that most of those transactions took too long to complete. And when you were in the credit card industry, the service level agreement you have with MasterCard, Visa, American Express, etc., is a very, very tight window. You might have, I'm just picking a number out of the air, like 1.5 seconds to do complete validation. That means going from the point of sale device through the store's network over to MasterCard or Visa or American Express or Discover or any other of the card providers, then over to your bank, and then all the other processing that takes place, and now you want to do AI. Sometimes there's only single low double digit amount of wiggle room that they have before they have to return back. So guess what? If that inference off the platform takes on average 40 milliseconds, sometimes maybe it can finish. It's in the same data center, so the speed of light is doesn't have to go very far. But even so, most of the transactions in this case, about 80 to 90% of them failed to meet within the SLA. And so guess what they did? If they're not going to meet the SLA is king, and they basically allowed the transaction to go. Meanwhile, the AI is completing, and when the AI completes, it says, "Oh, I shouldn't have allowed that one, but it's already out the door." That's what we again refer to as near real time, right? In this case, what they did is they would then mark that account as, "Hey, it's blocked," but meanwhile, that transaction went out the door. This client, by changing this one application to a very simple machine learning model, was able to say upwards of $20 million savings per year for that one app. This is not one of the very large banks, but it's a good sized bank in the United States. As soon as they found that they saved this amount with credit, they immediately went to their debit card and did the same thing, because now their inference goes from 200 milliseconds on average to about 1 millisecond, right? So amazing, amazing use of AI to be able to score all those transactions, saving a lot of money. When we come in and do an AI and Z discovery workshop with you, one of the most important things we talk about, it's all about the business value that it saves you as a client, right? So here's an example, streamlining claims adjudication. So going in a different direction here by being able to extract the necessary data from my, in this case, an IMS application, to be able to do a machine learning model to validate that this particular claim looks copacetic. And based on the training of what typical fraudulent claims look like, they were able to improve and to cross validate and not just for fraud, but for other claims that sometimes the data didn't match right, and be able to do it very easily. What's nice about AI also is that when you have new fields, for example, that come in, it's very easy to retrain a model to look at those additional fields, but it's a little more involved when I have to recode my application to take account of all those different things. So again, sometimes AI can augment your rules and to be able to have insights faster and to be able to adjust faster than changing a lot of code, right? So this is again automated claim adjudication, having AI in the mix for that thing. Then we have product recommendations. This is a well-known example. This is actually a client that has a public reference. The company's name is Swiss Mobiler. They're one of the oldest insurance companies in Europe. And they basically were not happy with the product recommendations that they were trying to give to their clients to upsell them an enhanced insurance product. And using AI and something called DB2 SQL Data Insights, which comes with version 13, they were able to give much more accurate recommendations that had a much higher percent of likelihood of them actually purchasing, which resulted in a 10% increase in their sales. and this took a whopping 2 seconds for them to have that enhanced recommendation of a security product. So they made their customer sat went up higher because the customers are getting a product that they really want rather than some annoying offers that they're not interested in. And of course, the insurance company gets the benefit of them upgrading their insurance. And then this is an example of clearing and settling of a batch process where a very large credit card issuer is able to not elongate their batch windows. This is a very complex use case, but it uses a combination of data from a data lake that is pre-populated into an in-memory cache on ZOS. So when they actually are running their their batch programs to clear and settle today's transactions for given retailers, they're able to do it in a very fast methodology. So under a couple milliseconds and not elongate their batch windows, which they were very concerned if they added AI into the mix that it was going to do so. There's a multi-model technique, which basically on the IBM Z17 allows you to sometimes use more than one model at a time. So when you have a particular request, this example, a request comes in for fraud detection. For 90% of the cases, it's very obvious that it's not fraud or it is fraud. If I have a high confidence, I just go ahead and I just take the risk abatement action. But in the case of I'm not very confident with it, I can now use an encoder large language model or another model that looks at some of the unstructured data. In addition to the structured data that was already analyzed and see if I can get an insight from a different angle. So I'm only invoking both models about 10% of the time. The other 90% of the time, I'm only invoking the high speed model. So the combined of both of them, we estimate at about 15 milliseconds, but for 90% of it, it runs in under 5 milliseconds. So again, this is a very enhanced way you can improve your AI on the platform. Fraud and sentiment analysis, government benefit claims processing. So this is an example again where it can look at both structured and unstructured data, medical history, for example, being unstructured data, doctor's notes, etc., as well as structured data of the actual claim process, and together get an enhanced insight and to be able to flag items that appear valid for auto approval, etc., right? And then this is a state government agency that wants to automate their custom license plate and disable placards in a very simple way using both structured and unstructured data. They're able to do so and only flag to a human being there needs to be additional investigation that needs to be done. Something that was a very manual process, a very remedial task, can now be done completely with AI using this multi-model technique. Anti-money laundering, this is an amazing statistic. Only 1% of illicit activity is detected worldwide. And part of it is because the money launderers are very sophisticated, right? So imagine if I could introduce AML screening into my instant payments. And so I'm doing a series of models for the instant payments. I'm checking is that individual payment fraudulent in of itself? Second one, is this following a deposit pattern, which is well known to money laundering, that I can detect a trail using what's called graph analytics to detect a pattern in the way that things are deposited, like A to B to C to A, for example, it might be a typical pattern. Of course, they're much more complicated than just those. And then I might also use know your customer free text data, all three of these things to help can come together to help give me a better insight. Even if I catch only 10% of the AML compared to the 1%, I've improved my application 1,000 times better than it was before. 1,000% better. I'm sorry, 1,000% better than it was before. And then advanced insurance claims, right? Where I might use a whole bunch of data to be able to detect both unstructured data and structured data. And when we talk about agentic in just a moment, I'll get to this in more detail. So let's talk a little about generative AI very quickly. Generative AI, again, this Spyre Accelerator. And again, the generative AI use cases would be for things where, for example, purpose-built Z workloads that want to leverage generative AI capabilities. So there's something called the Watson X Assistant for Z that uses the Spyre Accelerator for AI ops and for be able to have a view of the system and be able to change the configuration through prompts and be able to have it, the generative, all the capabilities still reside in your Z box, but also for business use cases, right? If I have financial documents or tax documents or photos, this interesting use case on the bottom right, where I have a photo of incoming cargo ships and I match it with the manifest, and I can through looking at the manifest versus what I see through the photos of that cargo ship, I can say, that doesn't match. What's on the manifest doesn't match. Let's flag that for additional screening, right? So just use cases where I don't necessarily want to be able to push that data off of the platform, and or I have tighter constraints on performance. This will give you good performance, but not within the scope of a transaction, right? Let's talk quickly about agentic AI. Agentic AI, of course, is automations, and I'm going to go directly to examples because I think examples are the best way that we can identify this. So imagine if a customer calls about a delayed shipment, we might be able to analyze the shipping data in real time. We might be able to provide immediate resolution options, etc. I'm going to go to a use case here that is very interesting. And this is like using a hybrid AI architecture. In this case, I actually do the fraud detection using a traditional framework, and I might be able to block the account if it's fraudulent. But that's not the end of the story. Once that thing has been marked as a fraudulent transaction, I now can kick off a whole agentic AI workflow for it to gather all the documentation that normally would have needed to be gathered manually and have a series of agents and MCP servers that are running to gather transactional history, customer profile, regulatory and historical fraud patterns, and provide you with a suspicious activities report, which is required when you're doing certain types of activities, for example, anti-money laundering. So again, sometimes the traditional can be married with the agentic AI capabilities. Here's an example of agentic AI here, where we have really a comprehensive solution with insurance. We're checking for insurance fraud when someone is making a claim. And how do we determine if it's fraudulent? A number of different ways. I can have a weather agent. The weather agent can go out as part of this claim processing and check what was the weather during the particular time and day that this person is claiming. They said there was a windstorm. Did we see that there was wind activity going on at that time? Can be done automated. What about looking at the photos? Do those photos match the weather and what the person claimed? And the damage analysis, looking at those photos or looking at other things, does that match what the amount should be? So again, you having this multi-agent architecture is just a great way of being able to orchestrate this entire workflow. And this is available using some of the technologies on Z. So with the remaining couple minutes that I have, 7 minutes, I'm going to walk you through what a typical AI use case might look like for just a simple machine learning, deep learning model to show you the different players that are involved and how you guys, most likely, most of the people on this call are like system programmer type of folks. What is your role in all of this, right? So let's walk through it. And this, we're going to use a typical example because it's very easy to consume. Credit card fraud detection. My credit card application is running in Kix COBOL, right? And right now, my problem in my shop is that the fraud detection isn't as accurate as it needs to be. The rules are highly prescriptive. It misses patterns that indicate possible fraudulent activity, and the fraudulent transactions escape and sometimes cause false positives unnecessarily to block the user's account. Nothing more annoying than when you're traveling and you say, and your credit card doesn't work anymore when you're just doing normal activities. So it's both, it misses fraud and it also, the rules also mark it as fraud when it really isn't, right? So both false positives and false negatives, right? So the solution is, let's talk about machine learning to augment our existing rules. But we have some things we need to consider: service level agreements, security concerns, cost to add the application, trustworthy results. Can I explain the results to a human being and meet regulatory compliance if I do this? And what skills do I need to implement this solution? So again, this is the life cycle of a model, is that we're ingesting a bunch of data and preparing that data to run in a model. We're going to train the model with a percentage of that data and then test it to make sure that model is in fact accurate. Then we'll actually deploy that model, and then in real time, when a request comes in, it's actually going to invoke that model, right? So that's the step. Now we're going to walk through each one of these phases. But it needs a bunch of other people. It's not just you as a system programmer in the middle. It's also about application developers, data scientists, and as well as the business folks, right? That need to be involved in the AI solution. So when we do an AI and Z discovery workshop, we try to have all these personas in the room together to be able to talk about this solution. So let's just talk about a couple of these things. This is really about as fast as I could possibly talk about it. The first one is to create the assets. So this is not your job. This would be the data scientist and or the data engineer that is going to say, what data can we look at to determine if a particular model can detect a pattern of fraud, right? And so typically they're going to do some analysis of that data, and eventually they're going to find whatever data they need. They're going to format that data in using a certain types of pre-processing code, which will transform, for example, non-numeric values into numeric values, because models need numeric data. Models are nothing more than a complex algorithm, right? And so it needs to have numerical data. Again, the first step was understanding the data, preparing the data in a form that the model can consume. It's then going to create a model using one of these AI frameworks that we talked about before. Then you're going to go ahead and train the model with that data. And again, the better the data, the more accurate the results are going to be. A certain percentage of the data they're going to be using to actually train it, and then they're going to use a certain percentage of the data that was not trained to test it and make sure that, okay, I know that this transaction was fraud. Does the model actually say it was fraud, right? And hopefully you'll get something where it has a high percentage of success. And then the data scientist is going to wipe his hand and say, okay, application programmer, I'm going to give you two pieces of information. I'm going to give you the data preparation techniques, which might be just a simple program, or they might just say you need to transform each of these fields into the following values. So if it's in Kix COBOL, I need to make sure those things are in the right numerical format. And he's going to actually give you the model, right? In some cases, that model can be deployed directly by the data scientist if you have like a REST API endpoint where they can deploy the model. So this is generally at the end of where the data scientist begins and where the infrastructure person is. That's deploying the asset. In this case, there's a whole bunch of places where you can deploy it, both natively on ZOS, or on a Linux environment. There's lots of things that you can run. Also, all these things in the purple box, LinuxONE can also run in ZOS through something called ZOS container extensions. That allows you to run LinuxONE binaries in an address space, right? And so either flavor of ZCX, Classic or OpenShift will allow you to run these frameworks there. And then, of course, there's OpenShift AI, which allows you also to run the AI deployment work. So again, this is where the models actually are going to live. The models are going to live in one of these environments, right? So machine learning for ZOS is a full-featured machine learning platform. This is a paid product. It's a one-time charge type of product that allows you to do ultra tight integration with your Kix, IMS, and batch workloads. It transparently leverages the accelerator and provides end-to-end all the way from explainability all the way to actually building your model and everything in between all in one product. DB2 SQL Insights, again, part of DB2 version 13, allows you to get through a set of semantic queries, an enhanced SQL query. I'm able to say what row in my database looks a lot like this row. And it has lots of capabilities in the base version. And then there's an enhanced version called Pro, which allows you to now incrementally train to be able to train not on ZOS, but on IFLs. And to be able to look at unstructured data. So there's some advantages of the Pro version. The AI toolkit for IBM Z and LinuxONE, all these things can run in any LinuxONE container environment. So that could be on any containerized environment that you can run on LinuxONE or on LinuxONE or in ZOS container extension, ZCX. So I can run all these open source frameworks in that area. I can also run OpenShift AI. If I have OpenShift running on LinuxONE Z, I can actually install on top of that OpenShift AI, which provides this entire framework for building, training, this, the soup to nuts in the OpenShift framework for your AI workloads. So you can run that also on ZCX as well. So you have options: Linux on Z, Linux One, or ZCX. Okay, so we have that, and now I want to actually infuse it into the application. So I have now the environment where I have the model. My data scientist has given me those assets. I've deployed it into that AI framework. Now what do I have to do from an application point of view? The application is going to call the model, and that's this purple box here. It's going to get the score. It's going to pre-process the data if necessary and invoke the particular model that's running on Z. And then it's going to make an if then else afterwards. It's going to say if the score is greater than such and such a value, I'm going to take the risk abatement path, which maybe could be invoking another model. Or it could be no, just going to fail it. Or everything looks good, continue on my normal path. So this is infusing into that. And we have a number of ways with machine learning for ZOS of how you can do. If you're a Kix programmer, how do you like to write 3 lines of code? I basically tell it which model I want to run. Here's a pointer to my input data, and here's me invoking the model. That's it. That's all you do to actually invoke the model. And then there's to set up the parameter list. You just have to set up the parameters with the correct fields per your data scientist of what format they want the real time values need to be converted into when I invoke the model, right? And then handling the response, some kind of if condition afterwards to say, okay, if it's 75% fraud probability or greater, I'm going to fail the transaction, et cetera, right? So all kinds of different options available in that space. And then the last thing, monitor the assets. So monitoring the assets is basically saying, I need to be able to have a trustworthy AI to be able to explain the results that come from the model. I can't tell someone for a loan application that the reason your loan application failed is that the AI model gave a score of 0.62574. That's not going to cut it. Regulatory issues will demand that you provide them in clear English the reason why the model was failed. We need to be able to provide those capabilities. And so with things like machine learning for ZOS or WatsonX.governance, which can be linked into machine learning for ZOS or linked into any of those other solutions I talked about, you're able to now get the explainability so that if someone comes in and says, why did my model fail? I can explain it very easily, saying the reason why is because your credit score, according to the model, was the number one contributing factor of why it rejected it. Your credit score was of utmost importance, for example. It also has a capability of drift detection in MLZ that allows you to see over time your model used to be more accurate and now it's less accurate. So with that, I'm just going to say, how can you get involved? If you want us, IBM is more than willing to come there and do a briefing to you to show the value of what maybe a little more detailed about what than what I just talked about here today. But we really would like you to do this discovery workshop where we help you identify the value proposition for you of the current investment that you've made. You spent a lot of money on your Z16 or Z17. That accelerator, if you're not doing AI in the platform, is just sitting there doing nothing. You say, well, I didn't pay for it. Well, you kind of did. That was wrapped in the overall sticker price of the Z box. So we want you to take advantage of that technology and improve the business value proposition for your organization. So we come and do these workshops all the time. I just came back from one last week, and it was a great. We're working on a use case in the insurance area, right? And we're doing another one in the travel industry this next week. So we'd love to come and do a workshop with you. And that workshop would lead to a proof of concept where we'll actually be with you there every step of the way. All of these items on this page, no additional charge for you. You've already paid enough and invested a lot with Z. We don't want to make any other things in terms of costs. All of these things can be provided for you at no charge. So here's more about the workshop. Please feel free to send me an email or the emails that are listed here. And this is what kind of the value proposition that it provides. So there's a bunch of additional resources here. I'll make these slides available to you. And that is all I have. I know we're 5 minutes or 4 minutes over. Are there any final questions that you guys have? I said a lot of stuff in a short amount of time. I just want to know if there's anything else I can help you with. There were some very good questions that you had out there, but are there any others that you'd like to ask?
I don't see any popping up now, Steve. I also just want to throw out there that if anybody does have questions they weren't able to answer during this session, as I mentioned earlier, I am going to get an email out to everybody. You can feel free to reply to me there, and either I can answer you, or of course, be in touch with Steve himself, who's really the expert here and probably providing the best answer to all of your questions. Feel free to reply to me, and we'll get you back in touch with Steve, and make sure all the questions you have are answered in the meantime.
Yeah, and I just want to thank Jerry and Sammy again for hosting this great event, and not just for this particular topic, but if you look at their archives, and there's lots of awesome topics that they have on a number of different things. You can really look to New Era as a good source for learning about the technology on this platform. So thank you guys for hosting this as always.
Yes, wonderful. Thank you so much, Steve. We always appreciate you coming out and joining us. Thank you so much. And of course, to everyone who joined us today, thank you so much. We appreciate everybody's enthusiasm and participation in these sessions. We look forward to continuing to do so, and hopefully, we hear from you again too soon, Steve.
Okay. Yes. Looking forward to hearing from you guys. When there is a PDF that they'll have available to be able to download from this. Is that right?
Yeah, we could do the PDF, and as I said, since we are recording, we'll be able to get this up live on YouTube. I can send the link
Oh,
to anybody
perfect.
who wants it. So, any way we can get the information out to you guys, we're happy to get that to you. Just as I said, reply to my email, and we'll make sure you get everything you need.
Okay, great. Thank you guys.
Wonderful. Thank you, everybody who joined us again, and have a wonderful day.